further down the page here, they've got this one. They are saying, yeah, do it with triangles. It's a matter of, preference. I prefer to stress the corresponding parallelogram, which is a bit more traditional in the sense that I think if you look in Newton's book itself, his very first picture is a parallelogram. Well, the actual picture is straight out of his book, Newton's book. And after he's dealt out the three laws, laid down those three laws with which you're familiar, law one, the spaceship keeps going unless it's stopped under its own momentum, the inertia of an object under its own momentum, meaning, you need a force to stop it. Law 2, F equals ma. Law 3, every action has an equal and opposite reaction. We kind of referred to it when we were talking about this reaction here. We need to think about the ground or the table reacting against the weight. Yes? Anyway, but then after laying down those three laws, the very next thing is talking about a force parallelogram, which is what we've been looking at. So we had a force parallelogram here, didn't we? And we can have here as well, they just haven't stressed it here, as Newton would have. He would have stressed the parallelogram aspect, where I think that's useful because you can think of literally a string pulling the particle in two directions. Whereas if you just look at one of the two triangles, you're going to need to look at the triangles to do the trigonometry. I mean, we did that here. We looked at this triangle, but we could have looked at that one. And the point is, a lot of people are not so aware of a diagonal here of a parallelogram going across. But Newton was conscious of that, and I think it helps to be conscious of it. So in order to do this one here, which is using the angles given to do the necessary trigonometry, just don't forget that when you do that trigonometry in one of those triangles, it's one of two equally good triangles here. So they're stressing this one down here. You could have used this one up here equally well. It's the same thing. All right. So their problem here is, okay, if you've got a string pulling with a magnitude of 10 in that direction, and then you've got another string pulling with a magnitude of 8 in this direction, could you please find out the magnitude and direction of this diagonal there? You've been given an angle from the horizontal there of 40 and below the horizontal of 30, but the horizontal is irrelevant. Just add them together, say, okay, this angle here is got to be that both of those make 75. It's not that 75 is a corner of or an angle of the triangle, but we can see that 180 minus 75 will be this corner of the triangle down here. And then we can do what kind of, we know that's 10, we know that's 8. If that's 10, then so is this 10. Yeah? So you can have it any which way very often with the geometry. But they're quite right that once you found out that this angle is what? 105, of course 180 minus 75 is how we know this angle here is. If that were 90 degrees, you could see you could do Pythagoras here, couldn't you? If that was 90 degrees, we'd have a situation of r squared equals 8 squared plus 10 squared, wouldn't we? But if that's not 90 degrees, we need to subtract double the product of those lengths. That's what the cosine rule says, times the cosine of the angle. So you've got 64 plus 100 minus 160 cos 105, if I'm not mistaken, but I may be.
For r squared?
For r squared, yeah.
205.
Lovely. So r is the square root of that, whatever that is. And then the direction here, we will need to do a little more work, won't we? Do we need the sine rule or something? Yeah, you're using sine rule. Yes, and then subtract this angle here from 45, I think. You might not be seeing it quite like that, but that's a plan, isn't it? If you find that angle there by using the sine rule, and then subtract from 45. So sine phi over 8 equals sine 105 over r, which we might as well write like that perhaps. So we want reverse sine of, and that's what you put in your calculator in the end. And what do you get? Are you finding this angle? What I've called phi? But when you had subtracted from 45, then you got 12.4 degrees, which is correct.